Okay, I'm hanging out with Mark Groves here on the Team Architect team. Mark, what do you work on?
I'm a senior program manager on Team Architect, and I work on several designers actually. I work on component designer. We're doing some interesting integration with work item tracking, and also I've built out the Model Explorer feature set. So
okay, cool. So we just talked to Cameron. Cameron kind of gave us the lay of the land, what you're doing in Visual Studio Team System 2010 with architecture.
Yeah.
You talked about the top-down, the bottom-up approach. What are you going to show us today?
Mostly just a top-down approach.
Okay.
So show you a set of UML designers we're planning for 2010. Okay. And kind of walk through some of the feature sets and kind of get you familiar with what we're doing.
Okay, let's take a look.
Okay. So for the next edition of the Architecture Edition, we've added support for several UML diagrams. So we'll create a new modeling project here, and we'll use our fictional Dinners Now application. So the modeling project is our new entry point into being able to create UML diagrams within Visual Studio. And as you'll see, you'll get a model project and a model definition folder here, and this kind of holds the backing model for all of our diagrams. Additionally, we have a Model Explorer that'll show you all the model elements that are within the model and visible or just stored in the model on from the different diagrams you build. So I'll start off here by doing what many architects or business analysts will start doing is actually work out the use cases that are required for this project they're working on. So as you can see on the new item dialog, we have some of the familiar UML diagrams that you would expect. We have logical class, activity, component, sequence, and use case. And I'll skip the layer diagram for right now. That's something that I think Cameron talked about, but we'll have a video for in a future segment. So the use case diagram here. So I'm going to create one called Payment System Use Cases. So when the use case diagram comes up, we'll actually be able to create both via the toolbox and the context menu our use case diagram. So I'll start off by throwing an actor on here called customer. And one of the other features we're really trying to improve on our diagramming capabilities is quick entry, so we can get really fast diagrams built and make it a lot easier to build things. So we got sticky toolbox capability, so I know I want to throw out here 4 or 5 use cases. So get those on here quickly, rearrange them a little bit, and let's see. The first thing that we have Dinners Now application is a little restaurant or online ability to order food from different restaurants, that is. And so the customer wants to be able to select a restaurant. They need to be able to select a meal. Place an order. And once they place the order, they got to set their payment details. And of course, we need to validate that their payment is going to be good.
We could just take them at their...
Yeah, well, we could.
Test them.
So now we can actually create the relationships between these. So we'll see that the customer is associated with selecting a meal, selecting a restaurant, and placing an order. But the placing order actually needs to include setting the payment details. These are all pretty standard UML constructs. So these are all UML 2.1 standard diagrams. So we try to keep as close as we could to the UML specification. And as you may have noticed, we've recently joined the OMG, so we'll be involved with that.
Yeah, Cameron was telling us about that. That's great.
So after we've kind of built out this use case diagram, so we've got a general sense of what's going on in the application, we'll build out an activity diagram. So what I really want to be able to do on this activity diagram is show the flow of data that's going to happen in this system. So let's focus on some of the ordered payment processing, because that's what we want to actually improve in our system.
Okay.
So just like the other diagrams, I can do things like, right click and add the initial node. And we're going to be able to, so I know I need a bunch of action, so I'm just going to throw these on here real quick. And we'll just quickly order a meal. Create the meal order. We have a request for payment. Approval. So we're going to use all this data in the different diagrams, such as activity and use case, to help feed the requirements for the software we need to go build.
Okay, so this is still the business analyst role performing this?
Actually, either business analyst or architects. Many times the architects are doing this to try to figure out the flow of what needs to be done. Okay. So it's not uncommon. I've been part of a lot of developers doing this too, so it's not really segregated to any one.
Sure.
So as I mentioned, we want to make this connector really quick. So because doing connectors is always a big pain in the butt. So let me connect this up because I know the flow. So we have a really simple activity diagram. Now, one of the big things that we're also doing is we built out this model explorer over here, and what this really enables us to do is show the data that you just placed into the model. So you can see we have our activity items along with our use case items. And so the next thing I want to show is I need to be able to actually figure out the sequence in the system. Now I kind of have a general sense of what's going on in the activity and the use cases, but I want to work on the validate payment use case. And one of the ways you can do that, it's really just kind of a couple different ways. One is start creating sequence diagrams first. Others, you can start creating structural diagrams, like component diagrams first. In this case, I'll just start creating a sequence diagram. So sequence diagrams are used for various purposes. One is, like I was mentioning, just kind of model out the order in which things happen. They also, as we'll show in a future video, the ability to actually see what's going on currently in your code. So we've added a nice little feature to be able to reverse engineer from code into a sequence diagram.
Nice.
So I won't show that today, but this is just really more focused on the requirements gathering. So I have this customer. So let me throw that in here. And since he's an actor, you get this little property here. You just double click and get a little actor symbol. This is yesterday's build, so we're still working on a bunch of the cleanup. So we have this Dinners Now website. So the customer's going to hit the website. And from the website, they're gonna actually want to create an order. So we need a way for them to process this order. And of course, we hope that they're able to pay for the order. So from here, now this is gonna help us kind of figure out what either the classes we're gonna build or the components we need to build, what each of these pieces need to expose. Okay. Right? So first thing the customer's going to do is I need to be able to order this meal. So I'll just create a message here called order meal. And then from there, the Dinners Now website, we're more into really software design now. We're trying to figure out, flesh out different parts of the system. So we're going to do a create message, and the Dinners Now website needs to do a create on the process order object. Okay. And then we're going to start getting into, we got to set some order details. This is really high-level design, not really talking about specific technologies yet. We haven't really decided is it .NET or not, or C# or whatever. So I want to be able to submit the order.
Yeah, I can see how easy it would be just to sit down with the customer at this point still and review this diagram in terms that really make sense to them. Right?
Absolutely. I mean, if you look at all the diagrams I've created so far, it's really about requirements. Is this really the flow? Is this really your business requirements? And then once the order gets submitted, we need to be able to figure out if the payment is okay. So we're going to process this payment. So just to kind of highlight what the sequence diagram. The next thing, and I'll be back here in a minute. We're gonna flip over, and now that I kind of have an idea of what's going on in the interactions of the diagrams or the components, let's actually start fleshing out some of the components that are actually in this. So we'll create a component diagram, and one of the things that is drastically changed in UML 2.1 is components. So I think a lot of customers out there in previous versions, such as Visio, didn't really use components as much as were available. But the spec really has changed kind of how components work. So we think there's a lot of opportunities, particularly in distributed system design, to use component diagrams a lot more for architecture. So we'll start out with simple web browser.
And what is, at a high level, what is a component? What does that mean?
That's one of the most overused terms in the industry, really. I mean, so how we think of it, and this I think most applicable to the Microsoft customer, is the kind of most likely an executable. It could be bigger than that, and it could be smaller than that.
Okay.
So it could be as much as a system, like your whole accounting system or something to that effect, or it could be one executable. At this level, you're not really deciding, is it one DLL or 100, right? You're just trying to break down the levels of composition of your architecture.
Okay.
So, for example, I'll add in here the Dinner's Now website.
So you're calling the whole website a component now?
Yeah. Okay. And so, obviously, this is going to be more than one DLL.
Yeah,
it's a very big application.
More than one server.
And what we can actually do here is, since the Dinner's Now website at this level is just one big box, right? Well, I can also build components inside of here. So we can define new components, and we can say this component is, let's say, the payment page, right? Something like that, right? Or a shopping cart. You can kind of break down this into several different pieces and actually design the internals of a component. We can also just collapse this down and hide the details. We also need, when we start talking about this, we need some way to handle the payment. So we got Dinner's Now payment engine. And of course, we're not going to do this ourselves, so we're going to go off to a third party.
So that's like a credit card processing system. Okay.
So one of the things that the big parts of building out components is determining which interfaces these components either require from each other or depend on from each other. So if you look at some of the things we did in the sequence diagram, we had this iPayment services that's really processing all the orders coming in from the website. So I'll just create a new interface right here and be able to say, okay, well, this is my iPayment service. Okay, and the iPayment service is actually used by the website. So you can go over to the Model Explorer and find the iPayment service interface and just drag and drop it and reuse it onto these components. So by default, what we chose to do was when you drag and dropped a interface onto a component, we thought maybe by default that was a provided interface. So what we add is this little smart tag, so you can convert this to a required interface. So this is really just saying that this website is dependent on the iPayment service. And we'll wire it up with the dependency line between these two, so we can kind of see the wiring diagram between what's going on. Then we can add some more provided interfaces. For example, we'll just say this is just the website, right? And that the browser's going to use that website. So as I mentioned, you can kind of go in and design more details here now. One of the things that is kind of interesting about this is that I've, at a really high level, I've designed out the whole architecture, but now I need to go back through and figure out, okay, what are the details? Who's going to process what? And one of the things that allows us to do that is let's go build a class diagram. So this is a UML class diagram. So those that are very probably familiar with our .NET class diagram as part of all the different projects. We've had a lot of features here in our class diagram, both to interact with that physical .NET class diagram and the UML class diagram. So we have the ability to transform classes from .NET to UML and back and forth. So well, that's probably a whole segment in itself. There's a lot of details in that.
Yeah.
But kind of want to show you some of the things that we're doing with the integration between the designers. So let's see. We'll just do. We're in a logical class. So I want to keep. I've started building out different elements in my model, like the payment services interface and such. Well, I don't want to keep rebuilding that, so I want to reuse that. So for example, when I drag out the interface out onto the component or on the class diagram, I get the interface representation of that interface instead of it being a socket, ball and socket type of relationship. So now here's where I can start filling in the details of what actual operations are on this interface. And so we can just do some quick data entry here. So we allow kind of to just type in your signature, and we'll just parse it to figure out what the parameters are. And I'll say credit card type. So now we just have the interfaces defined. So if you actually, we'll flip back to the sequence diagram, and you'll see something kind of interesting now is, so we have this iPayment services, and now that we actually have a real type that we defined in both the class and the component diagram, I can actually go and pick that. Let's see if I can find it now. There it is. So I basically just bound the iPayment services to that class that we defined. And now I'm also able to pick those operations. Okay. So the operations we defined on the interface in this case are now flowing through the sequence diagram. And now I'm actually wiring up this kind of really, really high level logical diagram that I built out to more details in the design.
Right.
So it keeps flowing down. If I go back to my logical class diagram, one of the things that you want to now be able to do is, now that we're starting to define out the interfaces, well, let's start going out fleshing out the details. Well, I gotta do the dinners now payment service class, and kind of one of the nice features I think that we added was the ability to automatically, when you start creating an inheritance between classes, we propagate those operations automatically down to the class, right? Yeah. And we keep that stuff bound together. So, for example, if I go back up to this interface and realize that I needed another operation like check status, that automatically flows.
Oh, nice. So
you really have little chance of getting your classes out of date with your interfaces as you kind of evolve that design.
Yep.
So let's try to think of what else. I won't show the pre-work again.
Right.
So that's kind of a real quick look through all of our designers. The other things that we'll probably want to do drill downs in the future are their ability to take these classes from a logical class diagram and push them down to multiple physical class diagrams.
Okay, and that's when you go to code at that point?
Absolutely. Since the .NET Class Designer automatically creates code, that's kind of our mechanism to go from logical to physical. So, as Cameron probably mentioned, one of our things that we're really trying to push for and really trying to figure out the details on is how do we make the UML designers at the logical level very valuable with all these domain-specific languages at the more physical level.
Right.
We have the kind of the bridging diagram, which is the layer diagram, and Also, we're creating a sequence diagram at the physical level, and of course our Architecture Explorer, which I think Suhal's going to go through.
Awesome. Sounds good. Looking forward to that. All right. Well, thanks for taking the time, Mark, and we'll keep in touch with you and see how this progresses.
Absolutely. Thanks.
Thank you.